Hello, geometry students. Today we're starting topic 8. So this is 8-1, right triangles and the Pythagorean theorem. Your learning target is that you will be able to prove the Pythagorean theorem using similar right triangles. You will also understand and apply the relationships between side lengths in 45, 90, and 30, 60, 90 degree triangles. Your vocabulary is, again, we've had this before, the geometric mean, media geometrica, the Pythagorean theorem, teorema de Pythagoras, and the Pythagorean triple, tripleta de Pythagoras. All right, so that's our vocabulary. And we have a couple of theorems which we'll refer back to. But the Pythagorean theorem is a squared plus b squared equals c squared, which you've seen before. And then the converse of the Pythagorean theorem, if a squared plus b squared equals c squared, then the triangle is a right triangle. I skipped example 1 just because it was proving the Pythagorean theorem, which is a standard, but we can also just skip and start using it. It'll make proving it easier. To satisfy safety regulations, the distance from the wall to the base of a ladder should be at least 1/4 the length of the ladder. Did Drew set up this ladder correctly? So we have, I'm going to just make it a little bit darker. We have 2.5 feet is how far the ladder is away. And it has to be at least 1/4 the length of the ladder, but we don't know the length of the ladder yet. And then we have this 9 feet. So we need to use the Pythagorean theorem to figure out what the length of the ladder is. So we have a squared plus b squared equals c squared. We'll use a as the shortest length, which is 2.5, and b will be the middle length, and then we're trying to find the longest length, the hypotenuse. I know that 9 squared is 81, and 2.5 squared, I believe, is 6.25. So I'm going to grab my calculator to add those, and then, all right, when I add them, I get 87.25. And then I need to take the square root of that, so I'll turn my calculator sideways, and square root, I get, approximately 9.34 is equal, or approximately equal to c. So is 2.5 at least 1/4 of that? So to figure out what it is as 1/4, I'll divide it by 4. And I get 2.34 approximately. So 2.34 is less than 2.5, so 2.5 is greater than. So yes, the ladder is far enough away. And that's important because you don't want to fall off of a ladder, and so making sure that the base of it is at least 1/4 of the length of the ladder away from the wall. It's a good thing to know. And we use the Pythagorean theorem in building a lot. All right, moving on. If you didn't quite catch that, you can fast forward or rewatch the video, rewind it, and pause it. For part B, the length of each cross piece of this fence is 10 feet. So this piece is 10 feet, and this piece is 10 feet. Why would the rancher build this fence with the measurements shown? What do you guys think about that? So we have it as a height of 6, a length of 8, and the beams are 10. Why might he want to build his fence like that? And we'll just pause and have discussion because there's no right answer to that. There are many right answers. So I'm interested in hearing your ideas. Okay, we will do these try-its in your groups and then go over it as a class. So we'll call on people to share how your groups solved each of these 2 try-its. For example 3, investigate side lengths in 45, 45, 90 triangles. Is there a relationship between the lengths of AB and AC? Right, well, if we are given a 45, 90 triangle, then the other angle has to be 45 degrees. And if you think of like a piece of origami paper, it's a square, right? If we fold the origami paper in half, so pretend like this is an origami paper, it's a perfect square. Well, the sides of a square are equal, so that means that that AC and CB are equal. But they're asking, how is AB related to AC? We can say that this is the side of a square and this is a side of the square. Well then, if we use the Pythagorean theorem and we said, well, a squared plus b squared equals c squared, a is s, b is s, so we have 2 of these s squareds is equal to c squared. 2s squared is equal to c squared. And then we take the square root of 2s squared. Using how we simplified square roots before, since it's an s and an s can come out and 2 stays in. So that is the relationship. If those are s's, then this is s square root of 2. And then that will be true for any 45, 45, 90 triangle. Whatever the side is, so let's say like the side equaled 10, then the hypotenuse would equal s square root of 2 would equal 10 square roots of 2. And same thing, like if you had a square with side 13, then the hypotenuse would be 13 square roots of 2. So AB is equal to s square roots of 2, where AC is equal to just the side s. All right. So let's try that. If we know that these are 45, 45, 90 triangles, then we can use that same property. And we can just label the other sides of the triangle. If that's 7, then this is also 7. And then this would be 7 square roots of 2. So what are xz? Xz is equal to 7. And yz is equal to 7 square roots of 2. Now, if they give us the hypotenuse, like on the second one, and they're saying, what are JK and LK? Well, JL is 12 square roots of 2, so these sides would have to be 12. So JK would equal 12, and LK would also equal 12. That's pretty cool, and there's a theorem about that, and it says basically what we just proved above if we have a triangle with a 45, 45, 90, then BC will equal the side square root of 2.